Ultrametricity to Infinite Matrices LIC. Myself, I am Talsani Dutin Reddy, Section CSITA, roll number 22951A 3326. Introduction. Since its introduction in 1975, the Sherrington Kirkpatrick model for spin glasses has been one of the major challenges for the physics interested in complex systems. Although it is a mean field model, the exact solution is still not completely certain. Nonetheless, it is known to the three that in the low temperature phase, the replicity symmetric is spontaneously broken, and this make the solution highly or non-trivial. In other words, it can be rigorously provided that it is not possible that the connected correlation functions of the spin at different points goes to 0 when the total number of spins n goes to infinity. Consequently, the probability distribution of the overlap defined below cannot be a single delta function as happens in usual model. The existence of fluctuating intensive quantities like Q implies that it is not possible that only one equilibrium state is present in the thermodynamical limit. As usual, extensive quantities to fluctuate when more than one equilibrium state is present, and consequently we could say with some abuse of language that is in the SK model for large values of n more that one equilibrium state is present. The presence of many equilibrium states implies that an analytic solution of the model should tell us something on the nature of these states, on their relative relations, and one of the probability at equilibrium of finding the systems in one of these states. Of course, this information should be probabilistic nature given the presence of the quadratic disorder in the system. Using the Replica formalism and was proposed almost 20 years ago, which makes some hypotheses of the nature of the states, the most notable being ultrametricity. Roughly speaking, ultrametricity implies that the distance among the different states is such that they can be put in a taxonomic or genealogical tree such that the distance among two states is consistent with their position of the tree. The replica formalism. In this paper, we make use of the replica formalism. We address the reader of reference for an introduction of the issue. Let for simplicity restrict the discussion to systems with the quenched random disorder in the Hamiltonian. A similar discussions can be done for system without quenched disorder, like structural glasses. If you substitute the average over the quenched disorder with the average over the size of the system, we consider a system with n spins categorized by a Hamiltonian where J represents the quenched disorder. We define Pj to be the portability distribution of finding two equilibrium configurations, and the same inverse temperature B over the overlap that being defined as Q is equals to Nx. Let us assume that in the large n limit, the function Pj does not become a delta function, otherwise we have nothing interesting to say, and therefore the function Pj has non-trivial shape also for large n. When this happens, we are interested to find out the probability distribution of the function Pj in the limit, where n goes to infinity for a given values of n different choices of j may produce different functions Pj, and we can introduce the functional Pn as a probability distribution of Pj at fixed n. We assume that the j have a given probability distribution. Eventually, we would like to know the assumptions. It is clear that it is extremely difficult to arrive to some general conclusions on these probability distributions without doing extra assumptions. We know show that two rather simple assumptions replica even equivalence or equivalently static stability and separability are giving very strong constraints. Let us firstly consider replica equivalence as formulated in replica formulas. As we have already stated, the properties of the probability distribution of the overlaps can be obtained in terms of the matrix QAB. Even in the low temperature phase, when the matrix elements QAB are not constant, we may expect no physical difference between the replica which have been introduced as the mathematical trick. Replica equivalence states that the observable which involve only one replica or a replica is symmetric the assume the same value. For example, replica equivalences implies that we must have that it turns out that for the responsible choice of the observable is a function. In other words, when we change that two equilibrium configurations under coupling J, the values of P and P fluctuate also for very large n, while the values of restricted on those pairs of configuration with the fixed values of Q does not fluctuate when n goes to infinity. That is a scattered plot of P and P should collapse on a curve in the limit of large n. In other words, overlap equivalence implies that in the case where a replica symmetric is broken and all overlaps fluctuate in the usual thermodynamical, and then these fluctuations disappear in the fixed question. In other words, overlap equivalence states that for a system composed by two replicas, the overlap is a good, complete or complete order parameter in the same way as the magnetization is for ferromagnetic systems. If we stay in the usual thermodynamic ensemble, there are many quantities that fluctuate also at large distance. However, if we consider the restricted ensemble where the order parameters taken a given value, all fluctuations at larger distances disappear and the connected correlation functions go to 0 at infinity. Results. Our problem is now that of finding the most general matrix Q, or equivalently the most general probability distribution compatible with the replica equivalence and with the Guerres relation and with separately, and then in particular with V will show that the most general matrix in the ultrametric one. We consider the case when few values k is equals to 3, k is equals to 4 or k is equals to 5 are allowed for the matrix element. The generalization to more than 5 values is straightforward, and we hope that our conclusion will still be valid for a generic P which have a continuous distribution of possible values. When the overlap of the matrices element can take only k different values, the function P is the sum of k delta functions. P of P is equals to x, ki is equals to k pi, four or more overlaps. In the section, we would like to sketch how the information we need about P of 3 can be systematically derived from equation 30. To make this section more readable, the formula related to the cases k is equal to 4, 5 we will be present in appendix. The method we use to obtain the results does not depend on k, so we will able to generalize our findings to whichever P, that is the sum of a finite number of delta functions. The many equation derivable form can be divided into three classes, those with 2, 3 and 4 different values of the overlaps. These equations are not independent, those with two respectively four different overlaps can be expressed as the sum of those with three overlaps. There are many ways of the solving equations. Here we represent the simplest one we are able to find. We have to consider only the equation with two and three overlaps, those which respectively correspond to the quantities. Conclusion: we have seen that in systems where the function is non-trivial and the overlap is a fluctuating quantity, systematic stability violations of arithmeticity may be found only in the systems for which the separability conditions does not hold and the mutual relations among equilibrium configuration is described by two or more overlaps. Thank you.